to talk about sampling distributions, and first we'll do a little bit of some review. First, a statistic is a numerical description of a sample. Some examples: for mean we have x bar, variance was s squared, s is standard deviation, and this p hat represents a proportion of a sample, a probability of some sample. A parameter, on the other hand, is a numerical description of an entire population. For that, we used mu for mean, sigma squared for variance, sigma for variance, or for standard deviation, and then p for a proportion or a probability. This idea of sampling distributions that I'm about to talk about leads us into talking about types of inferences. And there are three types of inferences. So first, exactly what is an inference? An inference is what's letting us move between a statistic, some kind of sample, up to a parameter, something about the population. So we do our experiment or our survey or whatever on a small group that's our sample, and then we make these inferences about the larger population. And there are three types of these. The first is estimation. This is where we actually estimate the value of a parameter. We know what the sample mean is. We're going to try to estimate what the population mean is. The next is testing. This is where we make a decision about a parameter. We're going to test claims and see if it is the way we hope it is or the way we want it to be. The final one is regression, and this is one we've already talked about. This allows us to make predictions about the value of a variable. So the first is estimating it, the second is making a decision, and then the third making predictions. So now that we've got that out of the way, let's actually define a sampling distribution. A sampling distribution is a probability distribution of a statistic. And it's going to be based on all possible random samples of the same size. So this seems very vague and kind of strange, but let's do an example to help explain exactly what a sampling distribution is. Let's suppose I give an 8-point quiz to a total of 4 students. This is a very small class. And my 4 students scored a 2, a 6, a 4, and an 8. My first step is to pick all of the samples of the same size. I'm going to consider samples of size 2. And we do this with replacement. So these are all the possible ways to get 2 students out of my 4. And I'm going to have a sample distribution of means. So I'm going to want to calculate the mean of each of these. And if I do, I get 2, 3, 4, 5, 3, 4, 5, 6, 4, 5, 6, 7, and then 5, 6, 7, and 8. And now I'm going to try to find a probability distribution for these means. My possible means ranged between 2 and 8, so now let's try to find their probabilities. Let's start with 2. We can see there's only 1, 2 in this set, so we have 1 out of a total of 16 different options. So back on my table, I'll do 1 out of 16. Now let's do 3. For 3s, I have 1, 2 3s, so 2 out of 16. Moving back, I'll write down 2 out of 16. Now let's do 4. I can see that I have 1, 2, 3 4s. So in my probability distribution, 3 out of 16. Now let's do 5. 4 5s, I have 1, 2, 3, 4 5s. So in my distribution, I'll have 4 out of 16. And you can continue this process. And if you do, you'll get 3 6s, 2 7s, and 1 8. And this is a sampling distribution. While we won't outright do these by hand anymore, they are going to be very helpful in our central limit theorem, which is what we'll talk about next.